Hello everybody. So, in the last class we have learned that which type of carbene will be remain as triplet and which type of carbene will be remain as singlets at their ground state. And after that we have started that is called persistent carbene. In the last class we have discussed little bit about this persistent carbene or stable carbene. We have discussed that this type of carbenes they are stable and they actually confirms the existence of these reactive intermediate species like carbenes, even though they are in general short lived, but this type of carbenes are stable and can be detected through various spectroscopy methods. In that particular topic we have discussed one specific type of carbenes that is called Arduengo carbene. That carbene, if we now draw its basic structure, okay, we are in the last class I have shown its structure. I am not going to draw the full. Okay. So, now if we see this structure for this particular carbene, and the next question come into our mind that why this is stable, why is it stable. So, there are few reasons behind this. Number one is that the electron deficiency is in the carbenic carbon is reduced by the donation of the nitrogen lone pair. So, nitrogens are having lone pairs, it can donate. Okay. So, first one is that electron deficiency is reduced by the donation of nitrogen lone pair. Okay. So, this nitrogen contains some lone pair, it can donate to this electron deficient carbenic carbon, and in that way it can increase the stability. Number 2, the carbene lone pair is stabilized by the inductive effect of these 2 electronegative nitrogen atom. So, these 2 electron negative nitrogen atoms are there, these 2. So, they will have this inductive effect, and due to this inductive effect they will actually pull out these electrons from this carbenic carbon, and that way it stabilizes this particular type of carbenes. So, next one is that carbene lone pair is stabilized, okay, by the inductive effect of two electronegative nitrogen atoms. Okay. Next is that number 3, this type of bulky R groups that actually prevent the dimerizations, though there are certain different type of these R groups are possible with very bulky to not that much bulky, but overall can say that presumably the bulky groups prevent the dimerization. Okay. So, the carbenes are in general dimerized because they are too reactive. So, in the presence of this type of bulky groups, they are not going towards the dimerizations. So, due to these particular reasons, these type of carbenes are getting stabilized. Okay. Next, we will learn another type of stable carbenes, that is called phosphinocarbene. Okay. They are also part of persistent carbene, and that has been developed in 1988 by Bertrand group, this one by Professor Arduengo group. Okay. So, this is by Professor Arduengo group. Okay. Now, in 1988 by Bertrand group, they also developed another type of persistent carbene, that is called phosphinocarbene. Now, what is the structure? They are in general like this. Okay. This is another way, these are called push pull carbene. Push pull carbene. Why? Because of the contrasting electron affinities of the phosphorus and silicon atoms. Due to that, these are called push pull carbene. Now, how they can be getting stabilized? Because of this type of resonance. Okay. So, these are called these phospphinocarbenes, and in general they are called push pull carbene because of the contrasting electron affinities of the phosphorus and silicon atoms. Another example of in this field is that and this type of carbene, they are also persistent carbene. In general, it has been found that there are certain type of persistent carbenes are there, which has been used as ancillary ligands in organometallic chemistry and in catalysis. Especially these N heterocyclic carbenes, they have enormous used in catalysis, especially in the asymmetric catalysis also it has enormous use, because you can easily induce some of the chiral part in these molecules and they can take part in the asymmetric catalysis. So, this type of persistent carbenes, they are very useful not only in organometallic chemistry, that again they are also very important in asymmetric catalysis. Okay. Now, we will learn another topic in this carbene, that is the generation of carbenes. Whenever we are talking about carbene structure, its geometry, its stability, then obviously we are always telling that they are in general very short lived, okay, and highly reactive, except few persistent carbenes, most of them are short lived. And next questions will be that how we can generate, how we can form these carbenes, these short lived species, because we want to use them for various type of reactions. So, how we can control its generation in different reaction conditions, that we will learn. In general, it has been found that most commonly there are photolytic formation. Through photolytic cleavage of certain molecules, we can generate these carbenes. Number 2 is that thermal. Number 3 is that transition metal catalyzed, or we can say mediated in certain cases. Okay. So, using these 3 different techniques via the decomposition of the diazoalkanes or the suitable precursors, we can generate carbene molecules. Okay. What does it mean by decompositions of the diazoalkanes or suitable precursors? It means that loss of small stable molecules from these diazoalkanes or suitable precursors gives us the corresponding carbenes. Okay. So, now we will first see that generation of carbenes using diazo compounds as precursor. Why this is most common? Because very simple, because if you see in these diazo compounds, there is a possibility to eliminate the very small stable molecule, that is the nitrogen. So, once we can eliminate that from these diazo compounds, then we can easily generate our required carbene species. Okay. So, diazo compounds is a very important class of compounds. Okay. This is the most common class of carbene precursor. Okay. So, it is something like this. Fine. Now, these type of diazo compounds, its stability depends again on the substituents associated with it. So, its stability is depending on its stability depends on its substituents. Okay. So, now what will be the simplest diazoalkanes? What will be? So, the simple diazoalkane is called diazomethane. Okay. So, CH2N2. In general, diazomethane can be synthesized obviously, but this is highly unstable. This is highly unstable. It is toxic and explosive in nature. Okay. So, it is very difficult to control it. So, during the synthesis of this particular diazomethane, it needs to be handled with a great care, okay, as it is highly unstable, toxic and explosive. So, it needs a proper care. Okay. In general, it is used in solution, usually in the diethyl ether. Okay. Now, if we see its structure, this is the diazomethane and stay like this, sorry. Okay. Or it can be like this. Okay. So, if the diazomethane can be generated, then this can be a potential precursor for the carbene synthesis. Okay. Now, first we have to know that how we can synthesize these diazomethanes. So, synthesis of diazomethanes. There are various methods to synthesize diazomethanes. I will utter few of them. Next is that synthesis of diazomethane. Fine. In general, the N-nitroso derivatives of amides or sulfonamides in presence of base generates the diazomethane. Okay. So, N-nitroso derivatives of amides and sulfonamides. N-nitroso derivative of amides or sulfonamides okay, fine. So, base that gives these diazomethanes. Okay. How it can be generated? We will see the mechanism. Let us say we have this N-nitroso derivative, okay. So, now we will attack over this electrophilic center, this will go, this will come back, then Okay. So, now fine. Once it will be like this, now let us say it has some protic solvent, it will pick up. So, okay. Now, this one, once it has picked up this, now this will have this hydrogen okay. Now, so okay. And once it is like this, then the elimination of this OH minus again will give okay. So, in this way we can generate this diazomethane. Now, in similar fashion, this can be again synthesized from N methyl nitroso N nitroso paratoluene sulfonamide you can try its mechanism by your own. It will be almost similar way that it can proceed and generates the diazomethane in presence of base. Okay. So, this is N methyl N nitroso toluene sulfonamide. So, this is the N methyl N nitroso toluene sulfonamide. Okay. From here also you can easily generate these diazomethanes. Fine. So, now we know how to generate the diazomethanes. Now, some applications of these diazomethanes we will learn. Okay. In 1981, some chemists in Pennsylvania, they were working on the synthesis of some antibiotic. During that synthesis, some certain part of that molecule, there was some carboxylic acid groups. So, they wanted to make its methyl ester. Now, they have used this particular technique or method to make these carboxylic acids into its methyl ester in one step, and the yield is almost quantitative. Okay. Let us see what they have done during that time. So, this is a highly substituted tetrahydropyran ring. So, what they had done, okay. So, in presence of diazomethane, the yield is almost quantitative. So, it was converted into its methyl ester. Okay. In general, how we can make one carboxylic acid into its methyl ester? If we see the conventional way, So, generally people are using carboxylic acid, they are making its acid chloride, okay. Then the corresponding alcohol in presence of base will generate this acid chloride into its methyl ester, or else they can use this one with the methanol in presence of acid. But these methods are having its own limitations and it cannot be used for all certain type of molecules. There will be lot of problems in many reactions. So, we need alternative. Here they have used diazomethane to convert carboxylic acids into its methyl ester as an very efficient alternative of those conventional methods of making carboxylic acid to its methyl ester. Okay. Now, we will see that what is its mechanism. If we see the mechanism, let us draw the carboxylic acid. Now, there is the diazomethane, this carboxylic acids, this hydrogen is pretty acidic. Now, this will pick up this hydrogen and okay. So, it will be plus CH3, okay. Now, this is very good substrate for getting substitution by the suitable nucleophile. Now, this has generated these two species, so I will not give like this way, rather we will say that these two species has been generated from this reaction. Now, this can nicely attack in SN2 fashion to this extremely unstable diazonium cation it will attack, and nitrogen is very good leaving group. So, it will eliminate nitrogen. So, it can nicely generate the methyl ester. Okay. So, the carboxylic acid in presence of diazomethane, it can nicely generate the methyl ester of this corresponding carboxylic acids. Thank you very much for your kind attention.